Okay. A 15-kilogram block is dragged over a rough horizontal surface by a constant force of 70 newtons acting at an angle of 25 degrees above the horizontal. The block is displaced 5 meters and the coefficient of kinetic friction is 0.1. A. Find the work done by the 70 Newton force. B. Find the work done, geez, that's a typo, by the force of friction. And C. What is the net work done on the block? So we can go ahead. Let's go ahead and draw this. So we have the, whoops. So it kind of looks like this. That's the horizontal, and it goes like this, right? So just in the, I won't draw it over the thing, but that's a 70 Newton force, 25-degree angle, blah, 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 blah. So the big picture intuitively, the block moves horizontally 5 meters. So only horizontal forces do work. Vertical forces matter indirectly because they affect friction, though. There are 3 forces to think about. The 70 Newton pulling force, which is angled upward, friction, because it opposes motion, and gravity plus the normal force. Does no work since there is no vertical motion. Work done by the 70 Newton force. The force is angled upward, so parts pull forward does work, parts pull upward does no work, so no vertical motion. So we only care about the horizontal component, right? So we can say F, the horizontal component, is equal to 70 cosine of 25, which is approximately 70 times 0.906, which is approximately 63.5 newtons. So the work is equal to the horizontal component of force times distance, which is equal to 63.5 times 5, which is approximately 318 joules. So that is part A. Part B, work done by friction. So, intuitively, friction always points opposite to motion. It always does negative work and is dependent upon the normal force. Because the pull is angled upward, it reduces the normal force, which means less friction. So the step 1 is to find the normal force. Vertical forces balance, which means that there is no vertical acceleration. So we can say the normal force, and I think I said the normal force is equal to m plus g or something, but that's not right. The normal force is equal to mg minus the vertical component f sine of 25 degrees. So mg is equal to 15 times 9.8, which is equal to 147 newtons. So F sine of 25 degrees is approximately 70 times 0.423, which is approximately 29.6 newtons. So therefore, N is equal to 147 minus 296, which is equal to, or 29.6, sorry, which is equal to 117.4 newtons. Now, step 2. Now that we have the normal force, did I already use the whole page? How do I scroll down? Dang, I did. Okay, step 2. Now that we use the frictional force, the frictional force, F sub k is equal to mu sub k, the coefficient of kinetic friction, times the normal force, which is 0.1 times 117.4, which is equal to 11.74 newtons. And the work by frictions, which is step 3, is equal to work by friction is equal to negative F, the frictional force, times distance, which is negative 11.74 times 5. Whoops, the time is 5, which is equal to negative 58.7 joules. So that is part B. Now, let's do part C. Let me erase this. Wow. Does it realize that gray is just covering the whole thing? What the heck? Wow, that's pretty useless. It's a terrible eraser. Okay, part C. What is the net work done on the block? Net work is just work added minus work removed. So, only two forces do work. Pulling force, which is positive, and friction force, which is negative. So the net work is simply 318 minus 58.7, which is approximately 259 joules. So that's question 4.